And yeah, I think there's a very interesting journey ahead to get us to that same level of 10 BPS performance. It's not the case that sort of the tricks that got us from 4 to 6 BPS and then 6 to 8 BPS are going to be the ones that get us from 8 to 10. And in my view, the core challenge here is really the labeling problem. It's how do you understand at a very, very fine resolution what the user is attempting to do. And yeah, I highly encourage folks in academia to work on this problem.
What's the journey with Nolan on that quest of increasing the BPS on Webgrid? In March, you said that he selected 89,285 targets in Webgrid.
Yep.
So he loves this game. He's really serious about improving his performance in this game. So what is that journey of trying to figure out how to improve that performance? How much can that be done on the decoding side? How much can that be done on the calibration side? How much can that be done on the Nolan side of like figuring out how to convey his intention more cleanly?
Yeah, no, this is a great question. So in my view, one of the primary reasons why Nolan's performance is so good is because of Nolan.
Mm-hmm.
Nolan is extremely focused and very energetic. He'll play Webgrid sometimes for like 4 hours in the middle of the night, like from 2 a.m. to 6 a.m. He'll be playing Webgrid just because he wants to push it to the limits of what he can do. And this is not us like asking him to do that. I want to be clear. Like we're not saying, hey, you should play Webgrid tonight. We just gave him the game as part of our research, and he is able to play it independently and practice whenever he wants. And he really pushes hard to push the technology to the absolute limit. And he views it as like, his job really to make us be the bottleneck. And boy, has he done that well. And so that's the first thing to acknowledge is that, he is extremely motivated to make this work. I've also had the privilege to meet other clinical trial participants from BrainGate and other trials, and they very much share the same attitude of like they view this as their life's work to advance the technology as much as they can. And if that means selecting targets on the screen for 4 hours from 2 a.m. to 6 a.m., then so be it. And there's something extremely admirable about that that's worth calling out. Okay, so now how do you sort of get from where he started, which is no cursor control, to 8 BPS? So I mean, when he started, there's a huge amount of learning to do on his side and our side to figure out what's the most intuitive control for him. And the most intuitive control for him is you have to find the set intersection of what do we have the signal to decode. So we don't pick up, every single neuron in the motor cortex, which means we don't have representation for every part of the body. So there may be some signals that we have better sort of decode performance on than others. For example, on his left hand, we have a lot of difficulty distinguishing his left ring finger from his left middle finger.
Mm-hmm.
But on his right hand, we have a good control and good modulation detected from the neurons that we're able to record for his pinky and his thumb and his index finger. So you can imagine how these different, subspaces of modulated activity intersect with what's the most intuitive for him. And this has evolved over time. So once we gave him the ability to calibrate models on his own, he was able to go and explore various different ways to imagine controlling the cursor.